Okay, when was the Y2 bug expected? 2000. What century was expected? Okay. I wonder if we are allowed to do this. I would assume not. We'll do that. Like this. I don't know how close to Haskell this is. We'll do show x. We'll put in some spaces and we'll go show xx. Is that allowed? While processing right hand side, multiple solutions in search of. Yeah. Yeah, that's not surprising. Multiple solutions found in search of show xs. Yep. Disappointing, but not surprising. So what we can do is we can just define our own type. So what we can do is we can go data cards, which is definitely not confusing. Do I need a where clause here? I think so. Types. I do not. I just used equals, including if I have multiple. I don't know how I feel about that. Okay, I can use a where clause. All right, that works for me. So what we can do is we can take a card, or let's do this. So what we'll do is we'll do cards, right? And so these are cards, and then we can do cards. We can do that. Cards, and I think that should type check. Oh, you can't tell between them? Alright, fine. I want to say Agda can. I don't know if that's true. Undefined name, make cards. What do you mean? Of course it's defined. I defined it right there. Oh, right. I need to produce a cards. Okay. Oh, yes. I guess that. Oh, it's, yeah. All right. This is not total. Show is not total. Possibly not terminating due to call. No, I'm pretty sure it's total. No, that looks pretty total to me. So, okay, maybe it wants me to do something like this. So if we go show make cards xs equals, can I go case, is it case xs of? Yeah, we can shadow probably. I don't know. Oh, because it's not strictly decreasing. Is that the problem? Oh, yeah. Let's go to that. Expected. I see. What's the syntax here? Where'd it go? I just saw it. There we go. Okay, so yeah, fine. Okay, yeah, and you still don't think it's total. Yeah, probably because I'm making a new one. But I'm surprised I can't figure out that it's not total. It's kind of disappointing. Hmm. Let's, one thing I want to test real quick is, can I get rid of that? Yeah, no, okay, fine. Yeah, what is the way to do this? Does it just... Error, it's not total. Possibly not terminating due to call the main.show. The thing is, I don't know if this is a limitation of Idris or not. But, oh, can lists be infinite? That's an interesting question. I don't know if that's going to pattern match. I also don't know if that's legally allowed because undefined name back. Okay, not the error I was expecting. Let's go find. Okay, it's vect. Because n is free here, so I think it's gonna complain about that. You don't know what vect is? Okay, we need import data.vect. Okay. Like that. Okay, so it runs, it compiles. Okay. Even pattern matches. Yeah, it's kind of disappointing. That I can't figure out that matching on this the n continues to decrease, and then at some point it will not be able to decrease anymore. That by doing this, well, doing this is what it's complaining about. That doing this will still terminate. It can't figure that out. Let's take a look at termination checking. We'll open that. Possibly non-terminating. That makes me uncomfortable because the point, or part of the point of using these dependently typed languages is that you accept that you're using a language that is not powerful enough to run into the halting problem. And so you can decide totality, especially since Idris has this backdoor trust me, or whatever it's called in Idris. I think it's called postulate in Agda. To be recorded as total, a function must cover all possible inputs, be well-founded by the timer sequence of possibly mutually recursive calls. It must be possible to show that one of its arguments has decreased. Not use any data types which are not strictly positive, not call any non-total functions. Main.show being reachable via main.show. Is it? Okay, let's get rid of this. Let's get rid of that. Do you still complain that it's not total? No. You're only complaining about it, yeah, with this, which is expected. It cannot decide that this will always be smaller than this. The function assert smaller defined in the prelude is intended to address this problem. That's sus. Simply evaluates its second argument, but also asserts a totality checker that y is structurally smaller than x.